anything that so there's a guy from Ireland who's very active on this.
Because I'm not paying for damn rent, I'll take one down, but I could see it on your.
And he's stopped like
You
his
know what I mean?
contract. And get people.
But I should think I'm not gonna pay for a room, sleep on the mountain.
This is not an academic question.
Well, I'm gonna go over here, I'm gonna go compare my contract. I'm gonna go to conference first.
Real problem.
Oh, yeah. When I tell them what their present over there doing, you know, they might go,
It's not a
there's
technical,
nothing online, there's nothing to online.
there's not gonna be a technical solution,
Yeah,
but
yeah.
there can be
I mean, I'll
technical
take them to get out
mitigations.
there.
Yes.
You know what I mean? Like right now.
Logging is the best.
Yeah,
way.
right. I thought about you when I heard that.
Logging is
Yeah,
better.
I got it on the phone.
Yeah.
And then I forgot to put my-
Taking down the content is better, arresting perpetrators.
You know?
Yeah.
And so
Yeah,
what
if
happened
the best
is-
you do is wrong.
I don't care.
Well, you told us not to take you to the hospital, so I mean, you know.
Well.
In general, I'm not-
Also, it's so sad.
Mom is from-
Of course.
He's not there.
And then I like,
There he is. All right.
That's where we are.
Get going, yeah.
Probably on.
Taking it a little extreme, perhaps.
You guys got it?
I doubt there are so many people.
Did you see the sign someone put under the Wilberforce?
Yeah, this is Stir.
And it's the-
Whoa, this is Stir. First order of business. Sit down. We need a volunteer to take minutes and a volunteer to be Jabber Scribe. We have gifts for those who are willing to do it. Fidget cubes. Last time it was spinners, this time it's fidget cubes. So anyone volunteering to be a Jabber Scribe or take minutes? All right. First one.
Excellent.
Thank you. Jabber Scribe, easy job. All you do is have to say the name who's speaking tonight. You can't proceed until we have one.
Someone please volunteer.
Please.
Ah, we got
A little more.
Thank you.
than that.
Richard.
With,
Appreciate it.
Nice
goodness
catch.
and timing. It was prompted.
Sorry, Sean. Okay.
John, you want to bash the agenda, right?
Yeah. Hi, John Peterson. So, Chris, we didn't actually do anything on RCD this time, did we? Yeah. So what has been happening, however, is people have been a bit concerned about the situation with STIR, certs, and indeed the entire bundle. So we put together a few slides and talk to you about kind of what's going on with that. And I think so we may take RCD off the agenda and do that instead. Well, let's do that. We'll do that right after the administrivia.
Yeah, well, good. Any objections to doing that? This is remove RCD and talk about certificates instead. Okay, great.
By now, you are probably all already tired of this. You know well, anything you say can and will be used by somebody somewhere. Okay.
Martin.
Something else? Okay, good afternoon, everybody. This is an update on the passport extension for resource priority header. Next slide. Background is, basically we're adding a passport extension in order to sign the resource priority header for various different priority services from mission critical to government priority services. There's also an RPH for civilian 911 and quite a few of them for DISA as well. The idea here is that these calls are given priority routing, priority queuing, priority access for wireless as an example. And so by having the authentication carrier sign the RPH, it will validate to a downstream carrier that they should offer the priority processing for that call session. Okay. The 00 draft was presented at an interim meeting, received comments. It was updated for the last IETF. And since then, we received additional comments. And next slide. Okay, so comment 1 was to clarify if the RPH attestation requires a second passport object with another signature in addition to the passport object used for the calling telephone number. And the answer to that is yes. It's a separate extension. This passport object is used to provide attestation of a calling user's authorization for priority services. This is necessary in addition to the passport object that's used for the calling user and telephone number. So basically, what we're attesting to is that this is a priority user and the priority level of the user. Okay, so an example would be ETS.1. Okay, next slide. Okay, other comment was there was inconsistent reference in section 5. The document requests value for a namespace, which is specified in this, So we updated the reference and clarified the text in paragraph 2, section 5. A new IANA registration has been defined to hold the potential values of the RPH array. See section 6.2. Definition of RPH claim maybe have one or more additional information field. Details of such RPH claim to encompass other data elements are left for a future version of this specification. And then in 6.2 was revised that this specification requests that IANA add a new entry to the passport types registry for the type RPH, which specified in this RFC. This specification also requests the IANA create a new registry for the passport RPH types. Registration of a new passport RPH type shall be under the specification required policy. This registry is to be initially populated with a single value for auth. Next slide, which should be the last one. The document is currently in working group last call. So far in working group last call, we've have gotten support, people reading the draft. But if any changes do come up, we will address those changes during working group last call. Thank you.
Any comments? Of course, we're substitute chairs, so we can't promise that anything is going to happen, but I suspect this is going to move forward expeditiously, given where we are. All right. What's next on the agenda?
The new topic.
Oh, yeah, certificates.
Certificates. Do you want to just go in and we'll take the job show for the next 2 months?
No.
No, let's.
Yeah, I got the slides.
You know, the week is early. If you're tired of looking at my mug already, I got bad news for you. So, oh, hello, good people. So, a thing can happen in the IETF process, and I've been around here a little while. I've seen this happen from time to time. We have these working group last calls. We have IETF last calls. I think I can get this to actually stick. Maybe not. We have working group last calls, we have IETF last calls, but sometimes enlightened people maybe are too busy to read things during that time. And they get to you afterwards, maybe even after the ISG has actually approved a document. In this case, our good friend Martin Thompson, you'd have a hard time finding someone who understands HTTP better than him. Had some comments that he sent to the list. This was actually around the last IETF meeting. And we've spent a bit of time trying to figure out what we could do to mitigate these concepts, these comments, without having to basically withdraw stir certs from the RFC editor's queue. I think, unfortunately, we're now persuaded that that is not going to be possible. We are going to have to withdraw stir certs very briefly. And you'll see, I'm going to go through kind of what I think the surgery is that needs to be done. This is important, though, because the working group needs to buy off on the things we're going to be changing in stir certs. So please do listen. I'll try to go through and explain what they are. If you see things that sound like showstoppers, let me know. Next, please. Okay, what is AIA? So unfortunately, this discussion has largely been between Martin and Sean Turner. Sean Turner is one of the world's leading experts on X509. I am not. I will do my best. Maybe Rich can pitch in for me if I get in trouble here to explain what the issues are. AIA is something that's a field that's in X509 that actually lets you reference like a web page, like a URL, an external entity through it. We use this in stir certs for one very interesting property. We have this concept of something called a TN auth list, which is a kind of list of things like OCNs, these service provider codes, or telephone numbers that can appear within a certificate. This kind of gives you a sense of what kind of certificate you need to have, be able to sign for a call to prove that you're actually the authority for the calling party number. The problem is it could get really big, so big that we were concerned there should be a way to do it by reference rather than just by values. You don't have this cert that has for 500,000 numbers right in it. So we said, let's just find a way to get like a web reference for that. So there's a couple of things we did in that weren't really as considered as they should have been. This is the first one of them. We didn't really say that this would be a constraint on any delegated cert. So in other words, imagine you have one cert that's for $500,000. Have 500,000 numbers. Martin Dolly wants one cert that's for like all the numbers that are at AT&T. So millions and millions of numbers. If he then delegated to a service bureau, to Cineverse to be able to do like the SMS stuff for some of those numbers, are they constrained by the set of numbers that were in the AIA of the original cert or not? We just didn't say. So we need to fix that. That's an easy fix. I think the text we've got there is going to fix that pretty much straight up. Next slide. This is another real kind of technicality of X509 of what it means for these extensions to be on the critical path. The problem is that AIA is a non-critical extension, and that's not something that we're going to change for a variety of reasons. But what we can do instead to kind of mitigate that is to put in a must for behavior for people that are using AIA for a particular context. That's what we're going to do. But that is exactly the kind of thing that gets your document removed from the RFC editor's queue. If you add musts, you got to go home and get it done again. So basically, imagine we're doing a last call on this. It'll be an abbreviated one. We're going to do this as quickly as we can to make sure that people are cool with this language. So if you're reading this language, and I know this is something that, again, probably only Martin Thompson and Sean Turner in this room, other than Mitch, care about. But like getting this language right is important for this. And if anybody's looking at this and thinks we got a problem, Rich, does this basically seem cool to you, what we're doing?
Wearing no hats because I have none works for me.
Yeah, okay. So next slide. This is where Martin is showing his HTTP literacy. So Martin's like, okay, so you're going to use AIA, and it's going to download this chunk of data that has the TN auth list stuff in it. Problem? Yes.
Sorry.
Yes, Mary.
This is bad here. But can I ask a question on the last slide, just
Yeah,
for clarification? Because that talks about limits a set of TNs, but is this then a requirement for service provider codes when we use those?
So it's for the entire TN auth
Okay,
list. The thing
okay.
is, we don't actually imagine this is going to be used for TN auth, for the SPCs, right?
Right.
It's only going to be used because you're not going to have 500,000 SPCs.
So this is
in
must
your cert.
support, not, okay.
This pretty
Okay.
much is here for this forward compatibility case for using actual TNs in this.
Okay, that's what I just wanted to clarify. Okay.
So next slide. So if you're an HTTP geek, you know that just saying, hey, there's some arbitrary data on the other end of this URL isn't actually immensely useful. You need to have some kind of a content capability, negotiation, some ability to say, I don't support that content, some ability to express how you express that content is actually going to be encoded. Unfortunately, what that means is we need a MIME type. So there are a couple ways to skin this cat, but this is actually, when you're asking how long this is going to take, how long we're going to have to spend outside the RFC editor's queue, it's those 30 days. Basically, that is the minimum time we're going to spend. Because there are these MIME doctors.
Maximum, right?
Oh, I'm sorry, yes, maximum time. Maximum time we're going to spend. It'll be like 2 weeks. That'd be great. So yes, we're going to take a hit from how the MIME doctors actually operate in this. But what this will allow you to do is be able to say, okay, there's now a new MIME type. What this MIME type tells you is the kind of data you're going to get when you dereference the URL that's in that AIA is going to be, I think the proposal is application, next slide, actually, I think it's in the next slide, to do like application TN auth list. We may do application TN auth list plus DER, like because we might have other encodings for this. Adam, you think that's a stupid idea? It's just because we might actually, I could imagine doing the TN auth list encoding and something that doesn't actually just look like DER.
So the issue that I have is the syntax using there. That's, I mean, as far as I can tell, it's based on the like XML plus something or JSON plus something, and you're reversing the sense of that.
Oh, so you want to be DR plus TN auth list.
Maybe, but I'm hesitant to start putting like DER plus things in there.
Is there actually an application DER at all already?
I don't think so.
No, it's application binary.
Yeah, so I mean, I would just say go ahead and put it in here with TN auth list. If someone comes with a different syntax, they can give it a different name.
Okay, works for me. I guess that's what we have here. So yeah. So that's our thinking. We'll do this and Martin will then be happy. And he's right in the sense of, especially for forward compatibility reasons, I can imagine a lot of different ways we might want to try to do this in the future. We should have media types that you can negotiate for this. Next up. Yeah, so this is more on me probably than anybody else. So like, I can't really make up my mind whether I think doing ranges with count or with prefixes is better. And we kind of have done this in a scattershot way throughout STIR. When we talk about ways to handle this, and in modern, this spills over into modern. Modern actually is much more prefix-based than it is count-based, though I think, like in this instance, we left open an extensibility in case you wanted to do count. Problem is, like, count really doesn't work rationally for large number blocks the way that our numbering plans are organized. And this classic example of this is if you have the TN, equals 1, 2, 3, the count is plus 1,000. What do you think happens? What happens to all these boundary areas? It's off number count with a, if you have a TN that ends in 10, you say the count from this is like 91. Well, what does that actually mean, right? How does it spill over and how do you do it? And more, one of the points he made as well is we did, for various forward compatibility reasons, put star and pound into the valid syntax for that number. What does count mean when star or pound? Now, this is actually a non-issue for reasons we can get into that have to do with how divert works. The only reason we have this in at all is to make divert work. And I'll be talking about divert again if you forget what that is, and I can refresh this if anyone really cares enough to talk about it. But point being, we're going to fix this. We're going to say you don't use count if there's star or pound. We're going to open it up so there is a possibility of doing an extension for prefix-based number ranges in this. So Sean knows the right place in the ASN.1 to add a ... that'll make it so we could in the future put something in that we don't have today. Right now we pretty much only have count. So yeah, we're doing that. And this is a non-trivial fix. Again, this is all, it's a bit technical, a bit in the weeds of how ASN.1 works, which is why Sean should be here doing this instead of me. But there's a thing called Quick. I don't know if you guys have heard of this. Apparently, like all the cool kids like do Quick these days. That's why it's just us in here. But yeah, I think we got this. If these kinds of things seem confusing or scary, or reading this you do have a better idea, please let us know. Because like I said, we're going to whip this around to a new working group last call and IETF last call very quickly. So please do read it, understand it, know what we're doing. Next slide. So Martin also pointed out that kind of, especially with AIA, our security considerations for this aren't great. And there's a privacy problem with this. So the whole concept that an individual service provider might want to have a certificate that's responsible for like 500,000 numbers, and you can go dereference the AA and get that list of numbers. Well, that actually leaks some information, like in a non-trivial way, right? Maybe a service provider does want you to know what all 500,000 numbers are that they have that the service is responsible for. They only want you to know the one. And we have danced around this for so long. Like our original plan with OCSP as the way to handle this would be that you would do an OCSP query just for the calling party number, right? For a call when it comes in, if you're the relying party. And all you would learn from the cert is, okay, this cert is useful for this number, maybe among others, but it's not revealing what any of the other numbers are. We have drifted away, though, and are thinking about short-lived, how to do certificate freshness from OCSP to doing short-lived certs. So I think the right thing for us to do here is to add some text about short-lived certs and say, if you're worried about this kind of thing, probably the right way to deal with it is with short-lived certs. Is there anybody who has heartburn with that? This is actually one that I think matters in the sense of if anybody out there really thinks they're going to do certs that are responsible for a large number of numbers, and so to be clear, to me, a cert that's responsible for like an OCN, I can go interrogate a database and tell you every telephone number that's associated with that OCN, right? Those things are interchangeable quantities to me. So if you give someone a cert that's for an OCN, they're gonna be able to know what the numbers are that cert is responsible for. If we want something that cuts that up more finely, the best answer we have now is short-lived certs. If anybody thinks there's a better answer than that, I'd like to know what it is. And of course, we have this whole story about like Acme and about how it's going to do short-lived certs. There's like the star stuff there. There's this whole adaptation for this. It's all going to be rosy. It's all going to work. It's going to be easy, and it's going to be secure, and it's awesome. So that's it. That's what we're going to do.
John,
Yes.
short-lived certs improves the situation, but if the cert has a list of telephone numbers, you get the list.
Sorry, no.
You
So
only know it for a short period of time. You get the list.
the point of the Acme short-lived cert thing is this. This would be purpose-built for calls. And this is what this star stuff in Acme is. So if I have like an Acme account that says I have responsibility for 500,000 numbers, if I need to sign for a call, I go from Acme and acquire the cert for that one number to sign this one call.
That's the
Sorry,
part you have to
maybe I didn't explain that. Yes. So this is part of the way we've written this up in Acme. We have a short-lived certs document that says this in STIR that we're not talking about today, but because we're still figuring out how exactly the pieces of modern Acme and STIR fit together a little bit, and we'll be talking about that a lot in different places this week, throughout the week. But yeah, that's the plan. That's the best plan I've got so far. It could be there's a better plan. We've been thrashing on this for a while. So, but Rich likes that plan. Like I said, it's a trade-off from data minimization versus the RTT at the end of the day. You take the RTT hit. In this case, you're taking it, the calling party takes it, right? Because they have to go get the short-lived cert at the time that they're placing the call. That RTT hit can translate into post-dial delay, right? And so, there's no free lunch in any of this.
But it could be short-lived as in a week or as long
Oh,
as the
fair
SIM
enough.
card.
Yes,
Right.
that's true.
The context of short-lived depends, and it could be as long as your SIM card's good for.
Got it. Yes, very true.
So a couple of comments from Jabber, from Eric Berger.
Hi, Eric. We miss you. Why aren't you here to see us?
So going back to change number 3 here, getting funny.
Change
okay.
number 3, please.
Just quick observation that you should be able to send some questions over the media doctors and get some feedback pretty quickly on the DER plus DER, et cetera.
Sean has promised to hit send button on that mail the instant that everyone in this room says this is a good plan.
Excellent. He explains that his travel budget is $300, and that's why he's not here to join us.
Well, I can no longer bribe you, unfortunately, because of your changing employment circumstances.
And the question from him is, will there be a dependency on short-lived certs?
So I don't think we need to have a dependency. I think what we're going to put in the security considerations is there are going to be strategies that involve short-lived certs. We're not going to end up with a normative dependency on that in there. Now, somebody may barf on that right down the road. I can't promise they won't, but I think we can get away with it.
For what it's worth, Chris went. For what it's worth, when I did passport and dealt with the media types, we were dealing with, it's maybe slightly different, but I think somewhat similar, a plus JSON or something like that. And it didn't make sense in the end. So I think the argument back was, in fact, I advocated for that, but then got knocked down. So
Okay.
I think it would be similar here.
You just think we should.
I mean,
stick with this, basically?
don't take my word for it, but
Okay.
hopefully it's a similar situation.
I mean, the mime doctors will doctor this, and it will be doctored. They're like house. It's like tough love, but yes. So that's it. That's the plan. Everybody got it? People,
If there are objections, speak up now. It would be helpful to know about objections now rather than later.
because we're trying to do something fast with
Yeah.
this, right? We want to just like pull the trigger on this, get this back in the RFCA queue as quickly as we can. As I hear that there are people on mailing lists that are saying that we're jokers or something because
Well.
we're sitting on this. So
It'll have to go to the list, but still,
yeah,
it makes sense.
okay.
All right.
Are we doing Chris now? Or-
Chris, yes.
Okay.
So this should be pretty short. Last time we met, 99, I submitted a 00. We talked about it. This is the Shaken passport extension document to register the claims needed for Shaken. John had given me a comment about providing more detail about the use of attest and Org ID. I did that in the 01 submission. I didn't receive any other comments. And last time we talked about work group adoption, I think we were supposed to do that on the list, and I unfortunately didn't follow up on that. So I'll do that right here. But John?
Oh, I just want to say I think it's fine. Yeah. I mean, I don't think we needed much, right?
Yeah.
I just wanted to know for like the values A, B, and C,
Right.
somebody reading an ITF spec could know what they were, right? And so yes, that you went through and there's bullet points and they say what it means, and that's all we needed.
Great. Thank you. Any other comments?
So your intention is to ask for word group last comment?
That's correct.
Okay.
I'm assuming we'll take that to the list.
Yeah, you have to.
Yep.
Since we're not the chairs.
We
haven't done
adoption yet, right? We need to adopt.
Yeah.
This is- oh, it's
That-
not even a zero,
It's not
zero.
even adopted, it's still individual.
Okay.
Can we,
You can ask the sense of the room.
yeah.
Sure,
And then
sure.
post
We
it
can
on-
ask for the sense of the room. Can I have a hum for those who are, who believes that we should adopt this with the intention of pretty much quickly moving to working group last call? If you're in favor of that, both actions, please hum now. And if you think that we're not ready to do that, please hum now. Well, that's pretty clear. Yes, strong consensus there, but it'll have to go to the list.
Great. Thank you.
You know, maybe do OB first. Do OB first.
You want to do OB first?
Yeah.
Even though we said the other one?
Yeah. It's agenda bashing.
Hang on. Give me a moment to get back.
It's okay.
Adam, do you have a feel for how long we'll be without chairs? Without saying, you know what I'm saying?
So in terms of like London, or are you talking about like in the shorter term, getting things pushed forward over the next couple of weeks? I'd have to speak to them. I think that Robert's probably pretty much in commission. He just can't like sit for long periods of time. So flying to Singapore was a no starter, but I think that he can probably go ahead and push things forward administratively. that's, yeah, Ben and I are more than happy to assist pushing these things forward as well, especially getting stir certs back in the RFC editor queue. That's my number one priority right now.
Yeah, we're sorry about that. Yeah. So we're going to talk some more about my favorite topic, stir out of band. Next slide. This is the general slide. Just I talk about every time we talk about stir out of band. Why are we doing this? Why does this matter? So, you know, stir started obviously from this thing that was RFC 4474, which was the attempt to put an identity header into SIP. We built basically on the same concept for the way we approach stir. The problem with that, because it is in band in SIP, it kind of assumes that like end-to-end IP is the use case that it works for. You know, at best, it addresses a case where there's SIP endpoints, or I should say SIP services, at least on both sides of the call and internet in the middle. As such, it can't really help with some of these SIP to PSTN cases, or more importantly, PSTN to PSTN cases. Let's face it, not all of the world is yet SIP. I keep hearing encouraging things these days about how much of the world is SIP, which is good. I think we're attacking this in the right place, but I still want to have a way that we can make this work for as much of the legacy environment as possible, especially the transitional legacy environment. The real problem is so much of the things we care about in stir come from this IP to PSTN calling pattern. That use case of somebody on the internet is like placing a VoIP call, and that's going to hit a gateway, and that gateway is eventually in a sentence called the PSTN. It's going to end up trusting whatever it heard from the internet side to populate the called party number. The next thing you know, you have robocalling that it uses perfect impersonation. We were kind of responsible for that as the people that built this world of these gateways and SIP and everything else, and didn't really do the polish for that properly. And my enduring guilt about that is what makes me come back to this again and again and again. You know, and it's important to point out as well that like even some of these IP to IP environments may not pass identity E to E. And that was another one of the reasons that out of band was part of our strategy for this from the start. I know Henning's gonna be here. Henning, I guess, is not here yet.
Yeah.
You know, Henning would always put it that we needed to do both of these approaches. Early on in the chartering of stir, we decided to focus on the in-band case first and then get to out of band. We thought that we had that locked down. So that is where we are. Next slide. So what do I mean by stir out of band? And this is just my standard architecture document for it. It contains the concept, there's something called a call placement service. We'll get into a bit of how you might discover those and why they trust you. That's a lot of what I want to talk about here today. But the basic idea is if you have some smart endpoint, the only thing I mean here by smart endpoint is something that is both connected to the PSTN and to the internet and has, you know, general purpose computing to like run stacks like this. Some kind of smartphone, when it's placing a POTS call, a call that will go through the regular telephone network, has a capability to store a passport at a CPS, and the relying party who receives the call has some capability to retrieve that passport and to use that to basically get the same assurance you would in the in-band case. That's the big idea here. And again, these could be enterprises that are the smartphones I show there. They could even be like gateways that are run by service providers in a variety of cases. A lot of the ways that people I know as strategies are looking at getting, you know, legacy, smaller providers, rural providers in on the stir scheme is to have some kind of gateway that's going to do something not dissimilar at all to what we're discussing here. So next slide. That's just to show you the basic ontology of it. All right, so there's a couple obvious problems with this. You know, if there were a way that the originating side and terminating side could rendezvous over the internet normally, they just use SIP, right? So we have to be looking at cases where there's some discovery mechanism that lets the originating side find a CPS, some discovery mechanism that will let the terminating side know how to retrieve passports from the CPS, but not necessarily that like end-to-end connectivity you might assume, the routability that'll let you get SIP done through this. And making sure that there isn't just, because there isn't just going to be one monolithic CPS in the sky run by some monopolistic telephone services provider, say. No, there's going to be probably a plurality of these things that are going to be loosely federated, and they could be run by carriers, they could be run by service bureaus. I can imagine a whole bunch of different architectures for that. So making sure that for a given call that the originating side and terminating side find the same CPS and utilize it is one of the hardest problems of this. We're going to talk a little bit about that today. But mostly I want to talk about a more fundamental issue than that perhaps, which is how to make sure that the right parties are storing and retrieving passports at the CPS. There is a real risk in this that a CPS is going to be what we call in the IETF a per pass target. That is something that a state actor or just someone who generally likes to eavesdrop and try to figure out who is calling who for any number of reasons that we probably want to prevent, will look at the CPS as a way to harvest data, probably just metadata about who's calling who and when. And all of the tricks and design stuff I'm going to be talking about here is largely about how to design something like this that'll work on the open internet that hopefully will mitigate the risks that are associated with that. So next slide. And figuring out in the first place who gets to store passports at the CPS is tough. It might not just be that there's a smartphone there. As I said, there could be a SIP UA that is then talking to a gateway, and the gateway is the one that wants to be able to store a passport. I mean, it could be that that SIP UA at the start can sign and provide an identity header, but there's in that middle there, because you're just going to the POTS level, well, all that would be lost. There's no way to re-encode STIR into SS7. So there would have to be some step here that gets this up to the CPS so that it's available to the smartphone. The problem is, of course, that means the conditions under which entities can provision into the CPS passports for calls in progress have to have pretty broad and permissive authorization properties. And that got us looking towards a certain class of designs. So next slide. As I said, because we want to optimize for privacy, we need to assume that the calling and called party have no required pre-association. We need some way to store passports such that they can be found. There has to be some way that we can index these passports in the CPS that minimizes the information that the CPS has about calls that are in progress. It's just a data minimization exercise. We looked at a bunch of different semantics for this, and the main differences between this version of the draft and previous ones that you might have seen. We talked about a lot of options of different semantics for how you might ask, hey, is there a call for me at the CPS, or things like that. I think we have that locked down now to a concrete story that addresses the rough requirements that you see outlined on this slide. And we're going to talk about that a little bit right now in the next slide. So this is our thinking. Passports are always going to be encrypted going into the CPS. That kind of makes sense that they'd have to be at the end of the day if you're trying to minimize the data that the CPS itself can learn. And our thinking is, let's just allow pretty much anybody to store encrypted passports, and then we'll index them at the called party's key. In other words, we'll use the called party's key as the key in to the database that lets you find passports that have been stored there. There are a couple of properties of this that I'll go into why I think that's interesting. What this does entail, however, is that there is now a certificate discovery mechanism required as a prerequisite for doing this at all. And this is a known problem, and it's not an easy problem. And we can talk about Active Directories and LDAPs and things like that people use this kind of thing today. It's a non-trivial problem. However, if you can assume that that problem is solvable, I think the rest of this design ultimately is tractable. We can go through and talk about what we think that might be. One hard edge on that certificate discovery that we should make clear, and this is something that we built into STIR and Modern and Acme and everything else we talked about this, is the notion that there might actually be multiple entities who are entitled to have certificates for a particular destination number. And some of that might be that there's a carrier who just controls an OCN, right? And all the numbers in the OCN are things they control. They should have a cert that should make them eligible to retrieve and decrypt a passport that has been stored in the CPS. But then there could also be a service bureau they delegated to, or an enterprise that they delegated to, or an end user that delegated to, who might all have different keys. And so because of that, the key discovery problem may result in you learning multiple public keys, having to encrypt a passport to multiple destinations. And indeed, that can make this more complicated. In some respects, I think that necessitate us making sure that it was indexed by the called party's public key and not by the called party's number. I'll come back to that again in a minute as well. But once you're just storing encrypted passports, why not just let anyone retrieve them, right? Because like if you don't have the corresponding private key, you're not going to be able to decrypt the passport and know whether or not there's a call in progress. Now, of course, that requires that anytime there isn't a call in progress, the CPS still obligingly gives you a blob of data that looks like it could be an encrypted passport that you can try to decrypt. But of course, if you don't have the corresponding private key, you can't do it. So this is basically the way that we're trying to minimize the amount of data that is visible to the CPS. This is the core of the design. Make sure the passports are encrypted. Make sure that they are indexed and stored at the CPS under the public key that you are using to encrypt the passports. Then people that want to at least purport that they are the targets of these calls, that they've just received a call and they want to know something's going on, they would present basically that public key to the CPS, and the CPS would say, oh, here's the passports, could be one, could be more, that are stored here right now corresponding to your public key. That's the big idea. Do people get this? I mean, again, I'm kind of looking around, and I know that some people here don't care about out-of-band at all. The only thing in-band is important. But in the subset of people here, they're at least vaguely interested in the possibility of getting out-of-band to work. People think this is clear? You kind of get what we're trying to do? I see a couple people kind of nodding. Are there any questions about this part of the approach? Because this is the core of the design, right? This notion that to meet those privacy requirements, you got to encrypt the passports. You got to have a way that their retrieval will not reveal that there are calls in progress unless you can decrypt the passports, unless you possess the private key. I see at least people who are shrugging and are like, yeah, I want a little more than this, guys. Come on, like somebody get up and say something.
Chris, one clarifying question. So you're saying that the CPS, when there's not a call going on, it would just generate random data and encrypt it, pretty much?
Yeah, I mean, well, yeah, it'll be a blob that
the
doesn't look
response.
like it's an encrypted blob.
Yeah, okay.
So it does. In your architecture, the first,
That's a fact. Just do an architecture slide.
either this one or the smartphone to CPS, that connectivity is an IP connectivity, correct?
Yes. This here, the green is the POTS.
Right.
These here are IP connectivity.
So with that assumption, I think that initially you mentioned that there is no way that end-to-end IP is available, right, between these two entities and smartphones, right?
I mean, I wouldn't say there's no way, right? It's the internet. If they can discover each other's addresses, obviously they can send arbitrary data between them. The point is, we also are designing the CPS in such a way that it is specifically not a disintermediator. In other words, we could design the CPS in such a way that it is basically just like a SIP service, right?
Right.
And you go talk to it and it says, oh, the guy you need to talk to is at this IP address on the other side of it. This is intended not to reveal these parties to each other over the internet. Because again, we think that that is it's just another perpass vector. It's just another way that people monitoring this are going to be able to collect metadata about calls in progress.
Okay, maybe privacy or some other reasons they don't want. Okay, so that's the reason that it's not that always that, okay, IP connection is not possible. It is some other reasons they don't want to reveal their information.
It's trying to solve this privacy problem that has a lot of angles on
whatever
it.
may be the reason. So, okay,
Yep. So why don't you flip back? Rich, did that make sense? You would have a comment on that?
Yeah, so a question, if I get 20 calls a day versus 100 calls a day, I'm going to get more passports that will have to leak through. Now, most of them I can discard because I'll have seen them, but the volume that.
So we have some language in there about doing dummy requests for these. So for a while, actually, debate about saying anytime that you either store or retrieve a passport, you should fake doing the other at the same time.
Okay.
And you know, again, if you're paranoid about this, by all means, I would just randomly provision like fake stuff whenever you want, or randomly ask for fake stuff at some intervals.
I'm thinking more about some kind of, Martin will be better at this, but some iterator kind of URL scheme, right? Where you can say, last time I got call number 50, now I want call number 51 and give me only that passport. I just wondered if that's.
Yeah, so the real problem is that, again, there's so little entropy in this. All you've got is, the calling party number, the called party number, and a rough indication of the time at which the call was launched. And that last thing, it's vague. It's like, it's got a 5-second margin of uncertainty, probably, maybe more.
Yes, but 5 seconds would solve most of the problem he's talking about.
Well, so that's true. So remember, again, that these things have a short life cycle in CPS.
Yeah.
Like CPS is going to jettison these things.
Okay, yeah, that's fine. Just Seems reasonable, and given the constraints you're trying to solve, the problems you're trying to solve, yeah, it seems like a reasonable thing. I was just worried about data overload on the pulling down side.
Yeah.
But if they do actually expire, then it's okay.
So they expire, and also we do have a story, and I'll get to this a bit, that Ecker has done. John, if you read his mail about this, about trying to do flood control to prevent like arbitrary people from like posting just junk data into the CPS, so that so there's like 50,000 passports when you go ask for your number. So we have a story about that. He basically just wants you to go get a token that is a hash that you're going to unblind later, that'll like actually let you know that, yes, this person is authorized to store a passport at the time without revealing who they are to the CPS. That's the interesting part. Yes.
Okay.
Yes, Chris.
So that begs the question, what if you do have two calls going to the same destination party
I know.
simultaneously?
So so remember, so what can happen at any time is that there can be multiple passports. So remember, the calling party may end up provisioning like 10 passports, right? If there are 10 certs it finds in the cert store for this destination, it'll put them all in. And when you go then request, when you do your get for your public key, you'll get all 10 of those, and you can sift through them. But if let's say that there's an 11th one that's put in there by a bad guy, right? The 11th one, you know, again, provided this isn't a very clever substitution attack, and there is actually a section about a particular substitution attack in the draft, which may be what you're alluding to, but provided that the calling party number of the one doesn't match the calling party number of the call you receive, there's no race condition, right? This is the key thing. So if two people are actually calling me at the same moment, right? One call reaches me and the other guy gets a busy signal.
Yeah.
If I go look in CPS and there are two passports waiting for me, one is for the call I got and one isn't. So the one that's for the call I got is all I need to know that the call I got is valid.
Okay.
So that race condition, there are substitution attacks that are more subtle. Like if there's a callback service I can induce to call me at a particular time, there's things that are trickier to beat.
Right. No, I wasn't aware of the possibility of getting an array back of, because you said index on the public key, but if it's an array.
Yeah, so you need to get an array back. And we need to talk when we talk about what the actual HTTP binding for this looks like how that is going to work, right? Like, because people are going to be posting, you know, if 10 people are posting different resources for this, you know, I want my get to make sure that I get all those resources, and we'll make sure we get the RESTful component of that correct. And none of that's been done yet. That's all. I'm just trying to get people to understand the basic architecture and to say, yes, I get it. I think it works. This seems to solve the privacy problem sufficiently that this is worth doing. Then we'll go design the architecture, what you actually upload to the CPS, and like, you know, get down to the bits and bytes of that. I'm just still trying to get the high level architecture of this to a place where I think it solves the problem well enough to be worth us trying to figure out how to implement it. Next slide. So the benefits of this solution, of the approach we're talking about, the encryption really limits what the CPS sees. Like this actually, you know, you're never going to eliminate it entirely, right? So there's a sense in which, because these things have to be indexed by the public key, and you have to assume the cert store basically lets you turn telephone numbers and public keys and vice versa, you can probably figure out who one of the parties is to a passport that has been provisioned, right? That much said, you'll never know if it's a real call, because it could be like a dummy that is being just stochastically fired off every few hours or whatever. So there's things you can do that will weaken the CPS's assurance of this. But it really limits the amount the CPS can gather as useful and certain metadata. It's very difficult to pull the server to learn about calls in progress in this instance. Like I said, I think it's basically useless if you're always going to provide back an encrypted blob no matter what. I think unless the implementation of that is stupid in some way, that because the length of the blob or whatever it reveals things. So we need to make sure that that is properly done so that concerns like that generalize. But that's a solvable problem. Like I'm convinced that we can solve that problem. And again, I like using the index for the public key precisely because it works better than the calling party number if there are multiple certs, right? Because let's say that like the carrier has a cert, the enterprise has a cert, and the end user has a cert. If I go to the CPS and say, hey, give me all the calls for people who have called this number, I'll get back the things for all three of those different certs, and we'll try to decrypt them, and it's like annoying. So we just make it my public key is what I ask for. Who's encrypted the things that I know I can decrypt? Then even if there's like 50 right, potential entities that you end up putting passports in that are encrypted to different destinations, I only get the ones that I can actually decrypt myself. I think it's a useful property. I think that this is much better than anything else we could come up with for how to address it. And we really racked our brains on this for a while. Next slide. And yeah, so Ecker has some thoughts that he's done. And again, there's no protocol level specification of this quite yet. But basically a way to make sure that you just can't like DDoS the CPS with lots of bogus passports. Because if you can do that, obviously then a relying party in real time who has, just remember, you've just received a phone call. You want to try to figure out whether to render to the user or not, that the number is valid behind it. You do not have time to sift through 40,000 like bogus passports to find the one that's actually valid for this. So, I mean, I won't go into Ecker's solution in a lot of detail, but it basically involves having some pre-association with the CPS where you go to the CPS and you get basically like a pawn ticket from it ahead of time. That's like, hey, with this one ticket, later I can come and like provision, I can go store a passport with you. You won't be able to know who I am. So there's some cryptography that is fancy in that lets the CPS know, yes, this is the right entity I gave it to, but I don't actually know from this what the key was they used to prove to me who they were. This is why we have Ecker. He can solve problems like this for us in ways that I certainly cannot. But with that, this provides a rate limiting function, basically, that makes it pretty obvious when someone is just trying to acquire lots of tickets to like spam the system and things like that. It seems plausible to me that we can get something like that to work. And if we lick that, I think we've licked most of the major ways you could mess with this. Yes, Chris.
You'll probably defer to Ecker maybe, but you know, if you have a lot of clients requesting tickets, that looks like a lot like a botnet, you know, doing those types of things. And it would be hard to differentiate between those things,
So
I suspect.
the system that you use to get the tickets in the first place requires you to reveal your stir certs. So in other words, you basically need to have a stir cert in order to get the ticket. It's just that at the time you then go to store the passport eventually, you're not revealing your stir cert to the CPS at the time. So in other words,
uncorrelatable? That seems pretty correlatable.
so this, again, it's based on, I don't know if you read this, Rich, and you want to do a better job than me of explaining it, but.
Yeah, I don't remember any details. You can make a request signed by the stir cert and then get back an opaque number. I mean, the CPS might be able to correlate, but you should only talk to a CPS you trust. A third party should not be able to correlate.
Yeah.
Okay. I mean, we don't have to go too in depth, but just bringing it up.
I mean, you know, I think again, it's never going to be perfect, right? This is all just about like, you know, to the degree we can mitigating the potential per pass implications of designing a system like this. Because we think it's a useful system. We just want to find a way to do it that is going to be least impactful to end user privacy as we can.
So a small question about how to fix this. Have you considered, I don't know, the discussion there, to separate two entities, the one that actually gives you the token and where you spend the token? So if they are separated, it makes it more difficult.
Probably, yep. And again, if we're assuming that there is already, so, you know, it's also important to remember, we have this assumption that there's a cert store that you're interrogating, and I don't know if that's AD or LDAP or something fancier, right, to get certs associated with the destination, so you actually do the encryption. All the same concerns arise around that, right? So you have at least these two entities. The more decoupled they are, the better this works. And if there's maybe there's some trickiness we can do between those two, provided we can ensure they're not cooperating, that makes this easier. I mean, I think we've got it. We've got some moving parts here, right, that look promising to me, that we can get something that doesn't totally suck out of this. Anyway, next slide. Yeah, so service discovery is the other really hard part of this. This question of how many CPSs there should be and how you find them. Because remember, like basically the only shared secret that the two parties to this communication have is the called party number and the calling party number, right? The time, the rough time, you know, it isn't really a shared secret because all your adversaries know that as well, right? So like it's basically the only rendezvous data you've got to find a CPS is the combination of the called party and the calling party. We don't want to make a totally monolithic CPS or to have there only be 3 CPSs in the world. I mean, there's some K anonymity properties, right, that we get out of that, but it becomes just too attractive a per pass target the more concentrated this is. So, I mean, our thinking is there has to be some degree of federation. I would love to see at least each of the major service providers, say, have some set of these things. Maybe they divide up their own numbering space if they wanted to participate in this scheme, and I would assume that they all do. But those that are, I think they could reasonably field a federation of CPSs and divide up their numbering space between them, for example. I mean, I guess my best thinking about this is still, since you have to discover the cert anyway to encrypt to start with, probably that cert should just contain the field that tells you how to find the CPS. Like, because I think, you know, I don't want to chicken egg this too much, but people have studied the problem of how to find the cert for, you know, a particular destination identifier much more than they've tried to solve the problem of finding CPSs, right, based on the calling and called party numbers. I suspect that, I don't know if it's AD or I don't know what it is we're going to reuse for this, right? I mean, maybe there's something even better for this specific use case that we should be looking for credential discovery. But I would rather bootstrap CPS discovery from credential discovery is just my thinking today. I don't know exactly how to do that yet, but, and it may be in some use cases, it's honestly just, it doesn't even matter. I could imagine this being used in vertical silos. You know, if like Apple wanted to use this for iMessage, right? Okay, well, Apple just puts up like the iMessage CPS, right? And it's just clear from the apps that are engaged in it that they use it. So I also hesitate to be too prescriptive about it. I think we can propose some ways to do this that we think are suitable for the open internet, while still leaving open that in certain verticals, this is just going to be something that people are going to do in their own implementation specific manner. Yeah.
Max Bala, Cable Labs, sorry, before I forgot. Have you considered to use something like peer-to-peer networks where, you know, discoverability is not an issue there?
So I could use Brother Brian's reload stuff. We thought about that. We've looked at ledger ways of doing this. Actually, I know Cisco has looked at this and said, we think that there's a better ledger way to do this. It may, one size may not fit all in this, right? So yeah, I think we need at least one good story. I think there are probably a bunch out there. I mean, ironically, you know, since you know, Cisco, when they tried to do this with Viper, you know, but Viper actually had a lot of these properties. A lot. When I look at the way that OB works, it's kind of like we cut Viper up into these different slices and used Passport and used things from stir certs that weren't available to Viper, right, to build an architecture that actually has a very similar property. If we made it reload, we would really just be doing like a Viper almost, you know.
Reload would clearly work for this.
Yeah.
It's just, is it efficient enough? Would people deploy it? Blah, blah,
Would
blah,
people
blah, blah.
deploy it is the problem.
Yes.
You know, perennially finding what the anchor should be for a reload and getting that into the implementations was a big deal. But I mean, I will say there's a lot of interest in this tech, and so it could be that there's just enough implementation mojo behind it that you can you get one of those anchors up, you know, like maybe for us next week. Yeah. Anybody else? Any other bright ideas about service discovery? This is tough. This is tough. It just is. Yeah, I was just thinking. Actually, I hadn't thought. I'm looking at Barnes. I hadn't thought about like, you know, like the CT approach to the credential distribution for this, and then actually have like the CPS be built into the certs that are available in CT. That you could do like a ledger like that. That's actually not totally insane. You don't like that? Well, efficiency. I'm not saying it's true. So there is a real-time resolution component of this. With short-lived, you'd be screwed for that. It's true. Anyway, rather than free associate at the microphone using IETF time, we can take that one to the list. So next slide. I continue to worry about this as well. So this is the other end of a use case I showed a little bit ago, where the gateway was provisioning, was storing to the CPS. That's a great use case because, of course, in that use case, you can assume the gateway, right, does the key discovery, encrypts the passport, puts the passport up in the CPS. The converse case is much more difficult. So the passport's encrypted in the CPS, and there's a gateway that is going to be taking this from the PSTN world to the SIP world, who wants to take that CPS but does not actually possess the credentials to decrypt it itself. Now, this is a hard case, especially if there's like dummy, encrypted blobs up in the CPS that it might end up carrying. But that much said, in SIP we allow multiple identity headers, and some of them maybe for keys you support, and some don't for very legitimate reasons, right? For exactly the reasons you've been describing. If you're a particular relying party that is receiving a SIP request with multiple identity headers, some of them could be for the carrier, some of them could be for whatever. The long and the short of this is, the reason this is interesting is because I suspect we may ultimately need a SIP identity encrypted header for this specific use case. Or I don't know if it's a header, right? Maybe it's just like there's a parameter that we attach to identity that tells you that what's in there is an encrypted blob. But we get into like RCD and things like that, or anything that carries more like location data or anything like that within Passport, then it becomes much more privacy sensitive as well. And we may find there's a general requirement for the in-band case that falls out of how this looks because of these use cases and out-of-band for having encrypted passports be carried in-band within SIP. Does that terrify you, Chris?
No, I was just curious if you could do it within the passport, have the encrypted information, but I guess you still need the X5U.
Yeah, so
I don't know, just
yeah, so that's why I was looking at a different header.
and so
because
instead
you
of
can't
having a
actually
different
extract
heading.
the X5U, if you're the gateway who's then populating a SIP identity header, you can't actually get the X5U because you can't decrypt the passport, right? So we mirror the X5U basically from the passport in the SIP parameters of the identity header to that. You can't do that if you can't decrypt the blob.
Yeah, maybe just thinking more generally about encrypting things in the passport world in general.
Yeah, so it could be that we'll figure out a way to do encryption in Passport that isn't just block encryption on the entire passport itself, but within the passport, there will be individual components of it that are encrypted. It could be that there are strategies for that that are meaningful. The problem is like the claims, at least. I mean, again, the headers can leak privacy data, obviously, but the claims would always have to be encrypted. So maybe there are things where you want to just encrypt the JOT claims, but not the JOT header.
The difference between the gateway and the per pass snooper start getting pretty small when you start talking about that.
Yeah, I know. And we can talk about how much we think the data that leaks from the header is a problem.
Yeah.
The X5U will tell you something, and but again, so the ORIG, the desk, and the IT are all in the claims, right? So like the if the metadata collection we're most concerned about is the called party number, calling party number, and the time, right, that you're historically archiving. Like, like if you encrypt the entire claims object, then all that stuff at least isn't visible to the CPS or to the per passer.
Well, that's relevant to this scenario, but if it's in-band, then, you're revealing that information in the SIP invite.
Yeah, you're
anyways,
revealing
right?
it in like
So-
the from and the to. You often forget the practicalities like that, yes. But anyway, so this use case is what I'm still thinking about and what the motivations then might be to try to figure out ways to do encrypted passports actually for in-band for at least some limited cases. Like if there is, like I said, geoloc style information that's in the passport in some new claim we define that's under RCD, that might not be replicated elsewhere in the SIP header, in the SIP headers, right? And so, next slide. All right, this is where I really need to get. So look, we've been trying to figure this out for a long time. And our initial ways of thinking about this weren't that great. At this point, I think the ways we're thinking about this actually aren't bad. Like I think when I look at what the requirements are, we have enough of an architecture here that I think we could pull the trigger on this and probably build something that, does much better than it could, right? to do out of band. And remember, I mean, this is important precisely because, I mean, there are a lot of smartphones like this thing in my pocket here, right, that don't do a lot of end-to-end SIP necessarily. You know, an identity hacker could never work in band for this calling like some other device if this could generate it, but it has a POTS connection and an internet connection, and it could do out of band. This is like one of the big use cases for this. We can get it to work.
Yes.
And a lot of the actual problem is from these IP to PSTN cases that go through a gateway. Like that's like I don't know what the percentage is. I would be astonished if it's not over 90% of illegal robocalls are precisely in that call flow. Come from the IP world, hit a gateway, end up in the PSTN. Henning probably knows that number. Somebody probably does. So I mean, I think. Do you know that number?
I don't know that number, but I'd push back a little bit on that premise, because are the actors that are supporting that IP gateway willing to support out of band?
Oh, I hear
from
ya.
where the spam is actually coming from. It's not somebody on a cell phone.
So, but it's important to say it doesn't need to be the gateway provider that supports it in this instance. Provided, again, that the originating device, let's say my Skype client, supports it, and the terminating device, my smartphone on the PSTN, supports it. This all works without the gateway's intervention.
Yeah, smartphone case. Yeah,
Yes.
I'm more
But
arguing.
but the smartphone case is like the main case. All the illegal robocalling I get that I hate is on this.
Mhm.
Well, no, I don't know that that's true. I mean, the case that I really care about is my mom, and she's on a POTS phone. But putting a gateway to do the check
Yeah.
as a completely disconnected piece and only affecting caller ID in the net result sounds eminently deployable if the mechanisms we're describing really work.
You're talking about positive validation of legit people, right?
Yes.
Instead of, okay.
Correct.
Yeah.
Because we think about negative validation of and trace back of
I think that's a lot harder.
and
Well, so it's-
enforcement and things
It's
like that.
multi-pronged. Again, a lot of the stuff we're doing in modern, right? Unallocated and valid is like targeting precisely that, right?
Yeah.
So I mean, so there's no silver bullet to solve this overall problem, right? We're attacking this from like 4 different ways because you have to, and just all you ultimately do, and this is the best you can do with like 90% of security solutions, is raise the cost on the attacker enough that it is no longer economically viable for them to do what they're doing. And like I suspect we can get there with the right cocktail of components around this, and this is a piece of it. So I mean, you know, I guess I'm looking for a go, or maybe I should do something else, right? Like I don't have a better idea than this of how to try to deal with these cases outside of in-band SIP. I think, as far as I can tell, it works, or it probably should work. There's, you know, all the stuff we need to do, but the stuff we actually need to do is like the protocol design now. We've got the architecture, we've got the use cases. I think we understand what the properties are, the trade-offs are. We can execute this if the working group wants to see it executed.
Well, provided that you get a satisfactory discovery mechanism for CTS. Yes.
I mean, I think we can define at least one satisfactory. Well, again, I think the credential itself, having the cert itself be the CPS discovery mechanism is satisfactory. Provided, again, you think that the cert discovery problem is itself tractable. And there are reasons to be skeptical about that, but it's been much more widely studied than CPS discovery, right? And I think that alone is a sufficient proof that there is a non-insane way to do that. I mean, I don't know how you guys are chairs. I might be interested. Is anybody who thinks they have a better idea? We have a charter item for this, right? And like we have, this is a working group item document. The architecture is here. Is there anybody here who thinks that I should not proceed with Ecker and the Coalition of the Willing to try to make this into a real protocol?
I don't hear anybody objecting. Go.
Yeah, I think it sounds like our best bet.
Yeah.
Okay.
I mean, anybody's got a better idea, please send a draft in, but I think it's fine.
It's much better than it was like a year ago when I was on virtual interim calls being like, I got nothing. So
Yeah, it's certainly been interesting to watch the evolution. I'm not as worried about the discovery part of it. I'm more worried about protecting the CPS from just flooding it with lots of things. But in general, yeah.
I think Ecker's pawn ticket thing for this isn't bad. Check it. I mean, again, so it's just a sketch now, right? That's in the draft. But just read the sketch, and I think we
Sure.
can
I
make
think
that
that's
into
my
something
only
real.
concern. That's all I'm saying.
Okay. I think we can beat that. I think we have a good shot to beat that. Okay, so I'll start maybe getting this into the RESTful thing that it will probably look like.
Great.
We have another one of these, right? Divert.
Yes, we do. Divert.
Climb every mountain. Okay, yes. Divert. Some people say, out of band, that's like down the pike. We don't really read NAV for a while. I mean, and it's not going to be important for these carrier cases. Everybody wants this. Everybody I talk to is like, this is the thing that is going to prevent STIR from actually working, which is divert. There's this problem in SIP that when you send out a SIP request, you kind of throw it over the wall at a SIP network of intermediaries who make arbitrary retargeting decisions. You may have initially thought your call was supposed to go to this place, but due to call forwarding or all these other conditions, it in fact goes to a completely different place than you anticipated. The problem is, in order to prevent a certain class of replay attacks, baseline Passport has you sign over the original two-header field, the original destination of the call. And the reason why you do that is because if you don't do that, I can take a call from me to Brian, right? And, eavesdropper can capture that and in fact send it to Rich, right? And if, Rich can look at the request and see, oh, this is really signed to be for Brian Rosen, then he knows that there's a problem, right? And that something unusual may have happened and he should treat this call with more suspicion than you did ordinarily. The problem with that is it's not always easy to know whether or not a call should have been retargeted, what a legitimate retargeting for a call is. Sometimes it may be very obvious if you know what the original called party number was, because it's your office, right? And this then ends up at your home as a second op. You would say, okay, I can understand that this call was originally targeted for my office, but I know I have a call forwarding thing that sends to my house, so it's fine. Those are the sunny day cases. This is designed for all the rainy day cases where things get retargeted multiple times. And we have studied this in SIP forever and done a bunch of different things to try to activate the service data, service logic, to make it clear to entities what service logic had been executed during the processing of a call. Mary Barnes obviously took the lead on a lot of this with the history info stuff. This diversion header that Fleming do that originally? I forget who did that. It's like, back in the day, this ended up being, this is still widely used, right? It's one of these headers that the IETF effectively refused to standardize, that is still everywhere. So what we're doing here that's actually different is interesting. It's based on how the canonicalization stuff that surrounds Passport and STIR works. There's a lot of text in Passport and STIR that describe what kind of important semantic changes are to the destination of a call versus merely syntactical changes. Like if you're just eliminating, the dashes that somebody put into a dial string, or if, the call was originally carried by Skype to a target telephone number, but it ends up then going to Global Crossings network. So originally the URI, the SIP URI says this number at Skype, and then later it's this number at Global Crossing. These are merely syntactical modifications, is our current thinking anyway, to the destination. And STIR just ignores those. STIR has a canonicalization procedure that lets the signature over the original call still work if you're merely making those kinds of tiny modifications. We did a lot of work on this to try to make that work well. So that's what's most different about this from previous approaches. Also, history info and diversion were never signed. You had no assurance from the retargeting entities that they were actually the right people to retarget things. This is just it's like the via headers, right, that you get, or the received headers in email. Next slide. Step up to the plate, Mary.
Mary Barnes. I just want to make one comment on that. Your point that you didn't always know whether or not you could trust them or whatever, right? The thing is, there's service providers that are using that information for service logic and end applications, right? So
But they're assuming that they know what's going on.
they are assuming, I know, but this is why, and we'll talk about a little bit why I think you could make that situation better for them with some of this stuff, right?
Yeah, well, that
Yeah.
is part of the idea.
Right, but so anyways, we'll talk about it. I think we need more linkage between that and history info, some way of, yeah. Because I don't want us to end up redoing history info stuff in this, right?
And, I think there's a number of sentences which we're not. And part of that is, again, STIR was designed with this really strict charter. We're trying to beat these class of impersonation attacks and not to do this like kind of service logic preservation thing. There's a specific class of illegal robocalls, swatting, voicemail hacking, and we jettisoned a lot of things from the scope of this that we used to have in 4474 and so on, in order to narrow it down to just that. So I think there's kind of a charter-ish argument you might need to have depending on exactly what you want about that. I don't think if it's like just slightly adjacent, I don't have any problem pulling it in.
Okay, yeah,
But it depends on.
Well, and I'm still trying to work through the use cases, right? The ones that we have for history info, and I'll talk to Marianne as well, right? She spent a lot of time dealing with all this stuff, and yeah. Okay.
Andrew Allen, are you with us, sir? It's good. I know these things are fascinating. I know that SIP and security of SIP is so fascinating. So what does this actually do? What do we actually do in Divert? The basic idea is that we take a passport that already has been put into a SIP call in band, and we create a new one. When you're the retargeting entity, it's your job to look at that passport, say, okay, I received this, I validated it, looks good, I know who the original caller was. I'm now going to make a new passport referring to that original passport, and I'm going to sign it with the key that shows that I was the original destination, right? And that I am diverting it to this new entity. And that provides this chain of security that can let you tell that this retargeting actually happened because it went to the right person, the original correct destination for the call. That's the basic idea. Next slide. So if you have an original passport that looks like what you see above, it's going originally to first target at example.com there. What you have then is down here a div that says, oh yeah, in this new passport, the original destination was first target. Your new destination is second target. And you sign this thing with the key that lets you know that you were the first target. And that's different from how STIR ordinarily works. Ordinarily, STIR says you need to sign with the key that says that you have authority for the orig. And we are breaking that rule. That is a changed rule just for the special case for using div, where instead you want to sign with the thing that shows you were the original first target. And you can have a chain of these. If it ends up, there's complicated service logic that takes you through different places, you can end up with a chain of them. That was the idea. Next slide. But then I'm starting to work on this out of band stuff. So this is why, right, we were like, let's at least start doing out of band before we're completely done with the things we're doing with STIR certs and these related extensions, because it turns out it has this interaction. The problem does, because if you're putting, the original passport and the div passport into the same SIP invite, it's clear that they're correlated. However, when you're storing these things in a CPS and they're encrypted, the CPS can't even tell that they're correlated. So what do you do, right? If this is an out-of-band case, you're the retargeting entity, you got this call, maybe just over the PSTN. You go look in the CPS. You find in the CPS, okay, here's a thing that went to me, but I'm now going to retarget it. Well, you can make a new passport that looks just like the div one I showed on the previous slide. You can encrypt that. You can put it up there. The problem is the new destination can decrypt calls for its target, right, based on its public key, the one that the retargeting entity put in. But that isn't the key that was used to encrypt the original passport. The original passport was encrypted with the key to the first destination. So there is no way that second destination is going to be able to decrypt the new passport. So we got to fix it. How do we do that? How do we fix that? Well, there's a couple options, and that's what I'd like to talk to you about today. This is the interactive part of our discussion. I don't do this just to lecture, please. I want people to get up and talk about this stuff. So here's some things we could do. The retargeting entity could just encrypt a copy of the old passport with the new target's key and stick that in. As we're describing, the new target, when it goes to out of band, it will ask the CPS, hey, what are all the passports that are currently in process for my key? That is one approach. Hopefully you would then get both the ones in there. So the retargeting entity would be putting two passports in, the original passport that it's re-encrypted and the new passport that it's encrypted, both with the, encrypted with the public key of the new destination. Then there's another thing that I just wanted to kick the tires on, because this is the other way to do it. The draft has this concept in it now of an opt claim. So go to the next slide. And this gets a little closer to what do you encrypt to put into the passport. And as usual, I can't actually use tabs or organize things in a way that are legible. But the idea here in a nested divert is, in fact, there's this new field that's called opt. And what opt is it's the entire full form job, the entire passport of the original passport. So you could, there are two choices here. Either the retargeting entity copies and encrypts the original passport, puts it in there along with the div passport, or alternatively, it creates this one super passport, right? That just encapsulates the original passport within it and signs and encrypts the whole thing itself. So two possibilities. Next slide. So which is better? You could do the re-encryption, the original passport. Maybe that's simplest, right? I mean, maybe that's better. I guess, looking at some of these cases that may go beyond out of band, where you might want to have like an identity encrypted header, having a stronger correlation for that might make more sense for me. The problem is, this is one of these cases where the choices are close enough that there isn't a lot to lead me to do one or the other. These are the things I hate most, by the way, in all engineering design, is when the two things have very similar properties. And, I'm afraid of people. I've heard, actually, by the way, this shocked me. There are implementations in the field of SIP that actually know 4474 BIS or 4474 well enough that they barf on multiple identity headers. Because original 4474 stipulated there will only be one identity header. There are actually people, because we already said nobody implemented 4474. No. I've heard of at least two different implementations that barf if you do multiple identity headers in them. This is why we should have renamed the identity header.
I haven't seen that from Cricket, though.
So I'm dead serious. I can give you two. Actually, we have actually seen this in the field as people are starting to deploy this. By the way, people are deploying this stir stuff. It's pretty cool. No, that actually happened. So the nesting would get around that, for example. But I don't know. Give me some thoughts, right? I mean, right now, I guess my philosophy is maybe we should create opt as an option. Have that be something you could do. Not necessarily require it for any of these cases, but make it just a possibility that you could nest a previous passport for diversion purposes within one of these. Now, of course, multiple nestings is going to start getting ugly.
That's what I was going to ask about. Can you go back to the last example?
Yeah. So yeah, just imagine if you then were retargeted again.
Is that supposed to be there? The second, the div and the option? The div and opt?
Yes.
Or was it either or? That's sort of how I took it, but maybe I took it wrong.
Div in. I mean, you might not necessarily want to
Okay.
leave div in, because the information that's in div is is in here.
Okay,
Right? You
okay.
could extract it out.
Got it.
I liked it being human readable in this thing to show you what it was. I could see an argument if you're going to do opt to not do div.
Mm-hmm.
Sorry, I'm missing a first principle thing. How does the ultimate destination decode this?
I'm sorry. So yes, you decrypted it. The retargeted entity can decrypt it and decrypted it. So the retargeted entity does not put the encrypted version in. When it
But
nests.
how does the ultimate target decrypt something it was not encrypted for in the first place?
No.
Right? It's been diverted. The
No.
original guy.
You're not coming in there. So in this model, in the
that's fine.
nesting model, the retargeting entity, when it generates the second passport, it's going to sign and encrypt the whole
Oh yeah,
thing.
I got that.
But so this blob here, though, is unencrypted because the retargeting entity necessarily can decrypt it. So he just decrypts it and then puts the full form passport in after he's decrypted it. So this part is not encrypted anymore.
That's the job. That's the
Yeah,
pa-
that's just a normal
password.
job.
That's just the job.
Yeah, it's just a normal password.
It's
Yes.
encrypted, but it's the job.
No, it's not encrypted.
Not encrypted.
This is just a base 64 encode.
Base 60 and 4 encode.
I got, it's not encrypted.
Yes.
That's the part I missed.
That's the part of it. Remember, the retargeting entity can always,
It's encrypted, but it's not.
yes, it is. It's base 64 encoded, but the retargeting entity can always decrypt the job itself to put it in. Yeah.
So do you, for the multiple diversions, you probably want an array there, right?
No, it wouldn't be an array, unfortunately. What you would do is you would base 64 encode all this, and then that's
Oh,
what
yeah,
would be
yeah,
on
yeah.
the
Okay,
next
good. Got
one.
it.
And then for the next diversion, you
Yes,
would
yes.
base 64 encrypt all of that, and then put that in the op for the next one. Yeah. So look, this is why we're having this discussion, right?
Ada Roach, individual participant, and you put a bike shed up here. I just want to ask, did you consider just doing like escaping of this instead of base 64ing of it? It keeps it kind of readable. It keeps it kind of smaller.
I mean, we were just following job, right? So I mean,
Sorry?
we were just following job, right?
Okay.
I mean, again, job. So this is the way job does job. So I mean, it's
All right. It might be worth raising on the list, see if people have opinions on it. I mean, I'm particularly sensitive to the, we have div here and div inside, and then you have to address like what happens if they're
So-
different
Yeah.
and
for this case, it might actually make sense to you because I saw what you just described.
I mean, we had that discussion with the original passport discussions,
Yeah.
whether or not we should base 64 encode. I think we decided just to stay there because it's
We did that.
easy enough to decode it and not a very
I mean, the point is,
expensive
this is actually what appears like in the identity header, right? Right. Is like this chunk, and we wanted that to be base 64 encoded, not to be, JSON in an identity header.
sure. This was prompted exclusively by your comment of I want div here so I can read it.
Yeah. Okay. Got it. Yep. Yep.
Yeah, that I do agree. Just put the jot there.
So, but I mean, in general, so again, go forward one slide. So the main thing I want to understand is from a design perspective, we want to allow both the nested and unnested as options. Like I think they're similar in how they behave, and there may be corner cases though where like only one will work for this, and another corner case where only one will work for that. And I'm not sure I can foresee all ends in this.
Okay, Mary Barnes. So maybe I missed this somewhere in the discussion. But are you doing the nesting to maintain a semblance of order so you can kind of unpack it a certain way?
So we're doing the nesting as an alternative to having the retargeting entity re-encrypt this with the key of the target, even though it isn't in fact the original generator of the passport.
Right. So there is a logical order within your nesting effectively then. Is that correct? Or
There is always a logical order within. Now,
right.
now this is one of the ways if it were circular or spiraled.
Right. Well,
this
that's
is where
what
we get into.
right. Well, that's what
Well, so if there's a spiral, so here's the problem with the spiral.
yeah.
You don't have data. Go back to the 2 slides. Go back to the original one of unnested good. So like, if you imagine that you have divs and multiple divs because there was a spiral. Imagine that you're receiving like 6 identity headers in a SIP request because a spiral happened and it went through some of these things 3 times. This does not give you enough data to correlate that to vias, to
Well,
anything that
and this is
right.
and this
Now,
yeah.
the nesting, however, preserves the order.
Right. And this
Whereas
right.
this doesn't.
Right. And
Yeah,
that
these
was
these are exactly the kinds of interactions that are like in this one corner
well,
case.
and this was crossing my mind because this is where History Info has the index so that you can
Yes,
keep
it
track
has
of
the
these
index.
guys, right?
Yes.
So
Yep.
yeah. Okay.
Yeah, and you do. So nesting does not require that though, right?
Well, sorry, but then you get a good property with it, and then, right?
Yeah,
Well, I'm saying-
you wonder should you, if you would say use history, you should use history info, and then we could put the index in there.
That's what I think. Exactly. That's what I've been thinking. That allows you to unravel this a little bit more carefully, right? Or it gives you
Well, it correlates the nesting with
Right.
the history info that tells you not only what happened but why.
well, exactly. Yeah.
So I mean, Mary, if broadly the solution to getting you happy with this is to have the index from history info be an optional thing you add within div as a
Yes,
parameter,
yes,
I'm
yes,
sold. I'll do
yes,
that tomorrow.
yes. Okay, excellent. Okay.
That's a great.
I'll be happy for a little while, yeah.
Be happy for a long time, Mary. Why only a little while?
Chris, I don't know. I sort of do like, and I guess that's all I can say, that I like the unpacking of each jot as a nesting and taking step by step back. And I'm trying to think, like, would there be cases that I have to inspect every one, or I only care about?
See, what I am afraid of, right, is these policies, they're going to look at an identity header and be like, oh, I don't like 2 out of the 6 of the people just looking at the X5 view in the parameter of the identity header. I don't like those guys. I'm going to strip those 2. And so you can't, however, dude, I would be astonished if there are not SPCs could be programmed to do that, right? So, but the point is, it's because the thing about this, I trust 8 carriers, right? And like 4 out of the 6 of these identity headers have X5 views that I can attribute to those 8 carriers. So the other ones should be discarded. Nesting doesn't let you do that, right? Nesting, that will not happen in nesting. So, and also, it scares me if there's like 1 identity header restrictions and legacy things, and I'd almost rather.
So has someone got a use case for which the first option, the re-encode, is useful, or should we just do nesting? What's the argument for not just doing nesting?
That it'll get big. That if you do 8 nestings or something, these things are going to be absolutely massive.
But you want all that information anyways, right?
Yeah, I mean,
If you have multiple identity headers, it shouldn't be, I don't know, we'd have to test it out. Theoretically, it shouldn't be any, yeah, it's going to be about the same size, right? I don't know. I can't. Yeah. Yeah, I'm liking the nesting more and more, especially with the identity header argument, even just reordering or other things that could potentially happen. This keeps it that it has to stay intact.
Well, and so the next is, do you think we should say you could do either? Because remember, there's a sense in which you can do either. Like, as long as we still permit multiple identity headers, right? Like,
Yeah, right.
unless we make it so,
Unless you prohibit it.
unless we make it so you can't do div unless you use opt, which I guess we could say.
But do you want to make that meaning clear? Like if it's an identity header with a div in it?
Well,
You're
I mean,
defining both.
Yeah.
Is that a good thing or a bad thing?
Well, it could be a bad thing. I'm
I
I'm
would-
afraid there's like some
I
corner
would
case
say
that I'm not
defining
thinking
2
of
ways
that-
to do it is a bad thing.
So is there anybody here who thinks we shouldn't do nest, that thinks there's a good use case for doing, just the re-encryption in different identity headers? Let's just do nest then.
Yeah, so it does again. I was trying to understand if there is no out of band, right? Is there any problem?
So this all started from out of band again. So if
So
you
the
go,
problem, your next
in
slide.
nesting goes away. Yes,
Okay.
nesting solves the out of band problem. That's what
Okay.
that's why I designed nesting for, is precisely
Correct.
because I thought it solved that problem.
So the problem.
Yeah.
Yeah, okay. I just wanted to verify.
Okay, let's just do nesting. I think that's all I got. Next slide. Next slide. Next slide. Next slide. So, there isn't a lot else to do in this. If we're resolved on, let's just do nesting, then let's just do nesting. And I think we do one more cycle of this and let's be done, because people seem to want it. I keep hearing people want this, so let's just be done.
I would like to see some text that maybe Mary can help with, that of the interaction between this and history
Yeah.
info.
Yeah,
So if all you
I
want
can do that. Well,
optional
and
parameter within
yeah.
div for index.
Yeah.
I'm
Yeah.
sorry.
But you,
Well-
I would like to see more text than just that.
And that's fine. And also what I was doing is I had a draft, I just hadn't had time to go back to it, where I was taking the history info use cases and showing how it worked when you had this. And we can kind of see, you know, we can help develop the semantics there. Yeah.
I can't claim to be a history info expert, but is there always a one-to-one relationship between the identities used?
Almost certainly diverts will be a subset of the, again, precisely because, but it'll be, you know, history info will always be a superset in the sense that there will be no
Yeah.
things where there's ever a divert and not a history info for it. There'll be things where there's history info reflection, but not diverts for it.
Right, right. Because history info is purely mechanical. You retarget, it captures the information.
And the canonical thing will cause history info, but won't cause divert.
Exactly.
Won't cause that.
That sounds copacetic to me.
Yeah.
We got anything else?
No, I think that's it.
I would like to thank Brian and Rich for coming and helping out with this. Thanks,
Nothing to
guys.
it. Happy to help. Oh, okay.
Thank you very much.
Happy to help.
We have a jabber. We are jabbed.
I believe this is still Mr. Berger. Point for channeling. It was almost 4 months between Martin's identification of the CERT problem and the first discussion of it on the list, and another month before solutions were floated. Now we're talking about divert, which is in the critical path for STIR acceptance. During this time, we saw 2 out-of-band drafts. I'm hoping we'll see work finished on certs and divert before we see lots of work on out-of-band. I.e., can we finish the charter work of the working group that the entire world has said is important before we put much working group energy into out-of-band? Question mark.
It is in the charter now. We did get this chartered the right way. No, but point taken. I mean, this thing with search was unusual. And again, I think it was largely, I think we disagreed initially about how significant some of these concerns were, and that and definitely how much work would be needed to fix it. And so that kind of led to some delays as we passed through that. But as you can see now, I think we're on the right path. I think we've got answers to the problems. So yeah, but point taken, Mr. Berger. I know we need this. I know it's a big deal. So thanks, folks.
Anything else? All right. Thank you all for showing up. Appreciate it.
Go heckle the quick guys.
Anyone wants to sign the blue sheet?
Yeah, you haven't signed the blue sheets?
I did work on, he's happy to pull
Matt's
the
come up
XML
with this, we got
stuff in the RT editor and update everything, but he thinks he needs assistance from you to craft the security language. So he wants that
Thank you for
done, like, before he goes to bed tonight.
You know, like I said,
Yeah, I know.
Tell people you're gonna fix robocall and say, really?
I know. Wow. Yeah.